I haven't even graded them yet. I hadn't even made the answer key at that point. Okay, let's talk about, you want to look at which one you want to look at first? Which one's stable on top? Okay. Yeah, Ambrose is probably a little different because I'm spastic. All right. Number one was 5 points. That was the definition of the derivative. Remember, I got to take these back up. So if you want to make notes on a separate piece of paper, do that. I was looking for the difference quotient and the value. So the difference quotient itself there was worth 3 points. What are we on? Number one on non-calculator. And then the value where you evaluated was worth 2 points, unless you used alternate formula. Somebody in here used alternate formula. I can't. Was it you, Ren? Somebody used alternate formula. Anyway, if you used alternate formula, then it was just all 5 points in that one. But anyway, do y'all need me to work that one, or y'all okay? Are we good? All right, number two. I do want to go over number two. This one was 6 points. I gave you 3 points each for each of the two parts of the graph. I figured that would be fair. So you had this line, something like that, and then you had this piece of parabola, right? And it said that it had to be continuous. That was one stipulation. The other stipulation was that it had to contain the point -1, 1. So I was looking for that point -1, 1. Well, this we know would be the derivative of a quadratic, right? And I have to look here at where it crosses, and it crosses at -1. So that's where my max or my min is on my quadratic, is at -1. But then I need to decide if it opens up or it opens down. Well, because my derivative here is positive, that means it is increasing as it comes up this way. And then because my derivative here was negative, because this was the x-axis, that means it is decreasing. Y'all okay there? And then this, of course, is a quadratic. So the max or the min, or actually, let me go back. Quadratic means it is the derivative of a cubic. I'm going backwards on it. So the max or min here would be where it's crossing the x-axis, somewhere like this. So again, this is all positive, which means it's always increasing, so there's really only one way I could kind of draw it to go through there, and it looked like a cubic. Mine's kind of off. So I gave you 3 points for this piece and 3 points for that piece. Questions, comments, concerns? Everybody did really good on number 3. Those were 4 each for A and for B. The same thing with number 4. You did not even have to multiply it out if you did not want to. You may not FOIL was for the first one. If y'all need me to work any of those, holla. Y'all good? So that one was 4 also. Flip over number 5. Big mistakes on number 5. I was very surprised. Most people got part A. These were 4 each, by the way. Does anybody need me to work part A? Okay. So part A, y equals 5x negative 3 minus 6x to the 4th plus 1 over x. So remember, this is really just x to the -1, and I can do the power rule for each one of these when I get to the derivative. So negative 15x to the -4, because I'm still subtracting 1, minus 24x to the 3rd, minus 1x to the -2. You, of course, don't need that 1.
So once you have it like, I thought that the derivative on that was.
Part B was the real humdinger. Square root of x. This is the one that I told you the day before. Remember, the square root of x is the same thing as an exponent of what? I forgot the middle. 1/2. So what I'm going to do, I'm going to change this x to the 1/2, and I'm going to change this 3x to the -1/2. Some of you forgot negative exponents. Remember, if it's in the denominator of the fraction, that just means it's a negative exponent. And I can use that whichever way it benefits me. So here, the derivative would be 1/2 x. If I subtract 1, I get negative 1/2. If I multiply around here, I get negative 3 over 2x. And then if I subtract 1, I get negative 3x. Same rule there for both of those problems, but some of you just went, what? I don't even know. Number 6, everybody did pretty good on 6 if you remembered the derivatives there. Somebody name me work 6? Yes. All right, so 6 was worth 4 points, and so we know that y is the cosine of x over 1 plus tan x, and so the derivative here, we do the derivative of the top, which is sine, negative sine, times the bottom, minus the top times derivative of the bottom, all over the bottom squared. I would have left it like that if it was me. Yeah. It doesn't work like that. Work it out how? Oh no. You did what now? Negative sine x minus sine x tan x? And I put a circle around it? Okay, I'll fix it. Just distributed. I'll fix it. Okay. Okay, I'll give you a point back. My bad. Number 7. Most of you, 7 was easy. Does the curve have any horizontal tangents? Yes, it does. Horizontal tangents happen when the derivative, 3x squared plus 10x, when the derivative equals 0. So the big question here is, when does that happen? Again, you didn't have a calculator, so I'm going to take out an x. I'm left with 3x plus 10, and I'm going to just put each one to 0. So it happens at 0, and it happens at negative 10/3. It didn't ask you the specific point. If it did, I'd need to plug it back in to find the y that goes with it, but it just asked if it had it and where, so.
Wait just a second
here. 4. Those are not, I don't think those are the right points. It should have been like 0.5 and 2.6. So those won't work out right. I don't, something must have happened. We'll look at it. We'll look at it. Maybe the derivative wasn't right. We'll see. All right, number 8, A and B, those were 4 points each. Most of you got that. It was negative 12 for part A and 360 for part B. Y'all okay there? Speak now. Number 8, A and B, 4 each. Calculator. Oh dear, the calculator section. Okay. Part 1. Which of the following best describes the behavior of the cubed root at x equals negative 2? That's your key point there. Several of you said it could have been A or D, but it can't be differentiable at -2 because there is a vertical tangent at -2. So that was D. Number 2, we're looking for points that are not differentiable. This one was 4 points also, so I'm looking for points of discontinuity here, and since it is a calculator problem, I would need to graph it and also look for corners, cusps, vertical tangents, oscillations, that kind of thing. That was the bonus part of getting it. You could have just graphed it and looked. You have to, so that doesn't leave out just 2 and 4. That says go from -infinity to 2, and then skip all the area between 2 and 4 and pick up at 4. But it's just one specific point here at these. So you do -infinity to 2, pick up from 2 to 4, and then go from 4 to infinity. The way you did, you left out the whole middle part of the graph. So this has 2 vertical tangents.
Right.
And there's graphs here, there's graphs here, and there's graphs
Yeah, see,
here.
when I was graphing it, I couldn't see the in-between.
I gotcha.
Yeah, remember when I was...
Oh, and you have to go up really
yeah,
high
I
to
couldn't see
it.
the in-between.
Yeah, I hated that, bro. I couldn't tell what was going on. Wait.
They got like special reports here that nobody would trust people. People like it. Some of them were
Yeah. Actually, just write me a note on the front of it so I know what to go back and look at. Number 3, secant x. This one was worth 6 points. And the reason I made this one worth 6 points was because there were so many parts to this. So the first thing you had to do was you had to take that line. This problem probably had the average number of mispoints, the most number of mispoints on average.
So nobody got it.
No, a lot of people did get it all the way right, but there was a lot of partial credit here. All right, so the first thing I had to do was solve this to find the slope. I gave you a point if you found the correct slope. Okay, if you knew you had to find the slope from that, I gave you a point. Then you also had to find the derivative of secant x, secant x tan x, and you had to set it equal to 2/3. If you showed that, I gave you 3 points. So you knew you had to do the derivative, and you knew that the derivative had to set equal to the slope. So even if you couldn't find it, as long as you did that, if I saw this on your paper, that was 3. If I saw this somewhere on your paper, that was 1. I wonder if you put it in the calculator wrong.
Yeah, but I didn't get and it was radians.
No, it should be in radians. I'll look at it. Now, this is the part that I was really surprised that a lot of you struggled on. You don't know how to use your calculator to help you solve an equation. If this is a calculator problem, let it do the heavy lifting for you. So make it equal 0. And then look at the graph and find where it crosses the x-axis. Now you had to look, the domain was restricted between 0 and 2 pi. Okay, so if you went into your window and you set it between 0 and 2 pi, that's all you need to see so that you can see every place it's crossing. And if you did that, you would see that it crossed at 2 places, and it was about 0.524, and I should really be taking these out 4 decimal places because that's what's expected on the exam. 4. I'm pretty sure it's 4. I'll check and make sure. What? Okay. Okay. So secant, you would have to put secant x in your calculator as 1 over cosine. And I'm only going to go from 0 to 2 pi. I'm going to do my steps as pi over 2. Because that's what your Zoom trig would do for you. Oh, I didn't minus 2/3. Correct. Here, pi over 6 and 5 pi over 6, or 0.524 and 2.61. So that's an inverse, and we will get to inverse functions, and inverse functions are different than cofunctions. It's not the same. Inverse functions are restricted on their domains as opposed to the cofunction. I don't know. I'll still go back in my notes. All right, number 4. Most people got number 4. You had to do A right. You had to look. So this was 6 points again. But the reason this one was 6 points is there was 3 different things there that you had to calculate. And they were 2 apiece. I was nice to you on units this time. My initial plan was a point for the answer, a point for the units. But I let you slide on units this time. But make sure you do put those, because you'll lose your answer point on the exam if you don't. I know that sounds nitpicky, but I want y'all so used to writing it that it's second nature when you do it. So it was 18, 0, and negative 12. You don't need me to work any of those? Okay. All right, 5. I think most everybody got 5 unless you made like a sign error there. Remember that the derivative of cosine is negative sine, and then that impacts you from there on down. Questions? That one was 4, by the way. You had to do the derivative 3 times. Oh, really? I didn't know that. Yeah. That may be a program on your calculator. Well, you didn't do it on that.
They do. Honestly, like if we learn how to use a
You can do so much on your calculator. But, okay, so you learned something here too. Can everybody solve an equation using your calculator now? If you have an equation given, make it equal 0 and find where it crosses the x-axis. That will always give you the solution. Well, even if it's whatever equation you have, even if it's a linear equation, I mean, whatever, any equation in the whole world, if you make it equal 0, then you find where it crosses the x-axis, and that's your solution. All right, flip over. Okay, the particle motion problem. This was a very hefty portion of your grade. I counted each of them as separate problems because one was not necessarily based on the other one, and so I wanted to make sure. So they were 4 points apiece except for part E. Part E was 5 points. I gave you 3 points for finding the time and 2 points for the explanation. All right, part A, displacement. OMG, y'all. Displacement is not final position. Minus initial. What is the initial position? 1. When time is 0, position is 1. When time is 3, the position is 91. So you have to subtract those for total distance.
91 dice and 4 rotors.
Plug it in the position formula. So that S of t, so if you do S of 0, you get 4 times 0 cubed minus 2 times 0 squared plus 1, which is 1. You do the same process for S of 3, you get 91, and you just subtract those two values to get 90 feet. What you could have done when you got here, make sure you do the exponent first and then multiply, not multiply the exponent. So this is actually 4 times 3, 3 is 9, 3 is 27. Did you do 12 to the third? Did she do 12 to the third? Average velocity, again, average goes back to A-Rock. A-Rock needs points. So first 3 seconds means I need position at the first second. I mean at 0 seconds, and I need position at 3 seconds. And all you do is find the slope between those two, which is 30 feet per second. Sorry.
It wasn't even you. I did your stuff, and I was like, I did anything. I was like, I got 2 more. And then I was like, shoot, I got to do Joey's work too.
Like what time do
What time are grades due today? I don't know.
I've only got 4 more
Part C, IROC, find the derivative and plug in. Most everybody got that. That was 96 feet per second. Acceleration, of course, was the derivative of velocity, and you should get 68 feet per second squared. Part E is the part that was most missed on this whole question. At what values does the particle change direction? How do you know? It does not change direction when velocity is 0. It could change direction when velocity is 0, but it doesn't necessarily change direction. So, first thing I did was I found, well, where does velocity, which is the derivative, right? Where does that equal 0? Well, if you factor that, you find that t equals 0, t equals 1/3. Well, it starts at 0, right? I can be at rest at 0, but I can't change direction at 0 because I just started there, right? That's my endpoint. I'm the first, what did it say? First 3 seconds? Well, it doesn't really matter. I think I went to 3, but it doesn't matter. The 0 here is 1/3, and that's the one in question, okay? Yes, 0 is a 0 of this, but it can't change direction because it doesn't do anything over here. And since this was a calculator problem, what I did was I graphed this, but you could have thought about it if I have a quadratic that opens up with zeros of 0 and 1/3. This part's going to be negative. This part's going to, I'm not going over here because I don't need when t is negative, right? So negative, positive. So therefore, this is velocity, this is position. This was enough justification. Therefore, the particle changes position at time 1/3 seconds because the velocity changes sign there. Correct. That's what? Like this sign chart? I did a sign chart also. So 3 points for getting 1/3. If you gave me 0 and 1/3, I probably took off a point, I think. I took off 1 point. And then 2 points for you still could have gotten the justification part. I was literally looking for the change signs, or positive to negative or negative to positive in your justification, so that you knew. Number 7, 4 points each, A and B. Part A, how fast is the water running out? You don't know chain rule yet, but you will after today. So you had to FOIL that baby out and find the derivative. And so the derivative there would be negative 20,000 plus 5,000 t, and then all you had to do was plug 10 in for t. What did you do?
I took that 2 and I multiplied by 2.
You took what?
I took the 2 and then I did square and I multiplied by 250 and I did.
Okay, here's the reason that worked this time. Okay, yes, because technically the chain rule says we do the derivative of the outside and then we do the derivative of the inside. The derivative of 40 minus t is a -1. And since you're doing absolute value, it left the negative off. So essentially, yeah. But you probably missed part B. Okay. Average rate of change during the first 10 minutes, that's AROC. Anytime you see average, that is AROC, AROC, AROC. So at 0, you're at 400,000. At 10, you're at 225,000. So all you have to do is the slope between those two. And it is 17,500 gallons per minute. The bonus was 500. That was 2 points for getting the 500. All you had to do was put it on your calculator. Part B, is that a meaningful estimate? And I would say no, because if I go to 3, if I think about a step function, right? It's the step function. It's the greatest integer function. So it looks this way. If you can graph it and look at it too on your calculator. But if you think about derivative means slope of the tan line, does it make sense that the slope of the tangent line at 3, so this little piece right here is going to be 500.
What's the good answer?
I would say no, because the slope of the tangent line does not seem to be 500 at that point. But I just wanted you to make the connection between derivative, slope of the tan line, and that function there. When we derive, when there are multiple functions, we do the outside, and then we have to do the inside. So you have to get past the candy to get to the bubble gum. Okay. I just thought it was a good opportunity for some candy, to be perfectly honest. All right, so let's talk about what this means. If I have do you see the two functions here? The outside function being the sine of something, we'll call it u, since I've already used x. And then the inside function being the 2x plus 3. Do you see that? I got two different things going on in this problem. Sine of something. I'm just saying there's something there. There's something inside there. But the function itself is the sine of something, right? So I've got two functions. I've got the outside, and then I've got the inside. We all agree? When I take the derivative of this, and if I call this u, okay, what I'm going to have to do is I'm going to have to do the derivative first of sine, which is what? So if I do d, this time I'm going to do it with respect to u. If I do the derivative of the sine of u, then that is cosine of u. But then I have to take the derivative of the inside also and multiply. So I have to do the derivative of the function on the outside, and then I have to do the derivative of the function on the inside. If there was another one, I would do that also. I have to keep working my way in. So for this one, take the derivative of the outside and keep everything else the same, right? The inside of your blow pop is not changing as you break through the outside to get to the inside. But then once you get to the inside, that's when you take the derivative of it, okay? So watch. This becomes, if I want the derivative of the sine of 2x plus 3. I have to first do the derivative of the outside, which is what? Cosine, everything inside stays the same. And then I multiply by, what's the derivative of the inside? 2. This 2 doesn't go with this, it's just multiplied, so I'm going to put it in front so it doesn't confuse you quite as much. Multiply by the derivative of the inside. That's your answer. The blow pop's got an outside and an inside. They're different. And you have to get through the outside to get to the inside. A lot of teachers, one day I'm going to order them. Order sets of those. Have y'all seen those Russian nesting dolls? That you open it and there's a smaller one and a smaller one and a smaller one and a smaller one. Do you really?
It's a Christmas ornament.
A lot of people use that as the visual to help you understand chain rules. So you do the outside and then the inside, but I like candy. Let's do an example from your homework. And I'm going to work through as much of these as I can get until it's time to go. You have 1 through 24 tonight. These are straightforward. Remember, it's the introduction to the lesson, so these are easy. And we're going to work through them until it's time to go. We'll probably get through half of them in the 20 minutes we have left. Huh?
Wait. Is that a spider?
Shut up. No, it's not. I don't even believe you.
That's not a spider, that's
Number 4.
Mr. Vernon. Your dad has 2 brothers. I saw Mrs. Vernon.
So this one's set up a little bit weird. They tell you what the u is. They tell you what to use for the u. You really don't even need that to find the derivative of this. Okay, we know what u is. We know what that function is. How would I find the derivative of, okay. All right, secant squared what? 2x minus x. Remember, you have to leave the inside the same. So I'm just going to clean this up a little bit. I'm going to put the 2 minus 3x squared in front, just so I don't get confused and try to make it be a part of that secant. And then secant squared 2x minus x. That's the derivative. See how quick these go? Once you get the hang of them, it is super duper easy. Let's do another one. Let's do... Ooh, let's do 11. Number 11 says that the position, an object moves along the x-axis so that its position at any time. Y'all just thought you were done with particle motion, didn't you? You'll have it by the time we finish. An object moves along the x-axis so that its position at any time is given by x of t equals s of t. Find the velocity as a function of f. I mean, a function of t. That's the first derivative. You're exactly right. People died. All right. So everything you know so far about derivatives, product rule, power rule, quotient rule, all of that still applies, but now we also... Okay? Remember, when I do a derivative, I can separate the derivatives out with plus or minus. That doesn't impact anything, and that's okay. Leading coefficients can go out front, right? So I'm really doing 4 over 3 pi times the derivative of sine 3t. So, yes. So, that's exactly it. Okay.
So that's one. Wait, the 4 over 3 pi times sine 50. That's one.
That's just a coefficient there. So, what's the derivative of sine of anything? Okay. Positive, negative. Positive. So I got the cosine. Remember, leave the inside alone. Let it be. Let it be. Times 3. Chain rule. I had to do the derivative of the inside. Nope. You don't have to. That's that property. Remember, if I take the derivative of, let's say, 17x squared, I could rewrite this as 17 times the derivative of x squared. I can pull it out front. All right. Plus, again with the 4 over 5 pi. What's the derivative of cosine? Negative sine, keep the 5t, times 5, because I have to do the inside also. Now we can clean it up. 3, whoa, times 4/3 pi would leave me with what? 4 over pi. Because when you're doing chain rule, that sits outside of any function that you had before. So it doesn't go with this function, in other words. It's just multiplied. And so multiplication is commutative, so I could multiply these two together if it helps me with my cancellation. This is going to be minus. Again, I'm going to multiply this one and this one together because that helps me. It makes it 4 over pi again. Sine of 5t. Just this rule.
Now, why didn't you put? What is my on the AP exam? I wrote down below population. 5.
All right, let's do another one because they get harder. Okay. Number 14. Yeah. We'll do one. All right. Find the derivative, or find dy dx.
All right, let me do it. Wait, okay. Well, there's no inside. It's just all in.
There's not an inside, but look at what's outside. An exponent. I've got to do, or maybe instead of quotient rule, I could do what? Power rule, right? The power rule says, bring this around, right? -1 times, I leave all this alone right now. Subtract 1, right? Am I done? No, because I have chain rule. So that says I need to multiply by the derivative of the inside. Anybody?
Is it based on?
Is it cotangent or tangent? That's the derivative of cosecant. What's the derivative of cotangent? That's the derivative of cotangent. Multiplying which two? Because that's what chain rule says. Chain rule says take the derivative of the outside and then multiply by the derivative of the inside. Okay. I could clean this up a little bit if I wanted to. If I wanted to put the -1 to these two. Right? So that would change the first one to positive and the second one to positive.
Wait, so I thought if it's multiplied to the first, how can you just multiply to the second? -1 is 5.
All right, what did I just do?
We don't know. You took that negative and then you distributed it kind of to those two.
Okay, so this one I multiplied here and I distributed through. I distributed.
How can you multiply that negative?
You put it over to the negative exponent.
This negative exponent moved down to the bottom. And then -1 times all of this gave me what's up top.
So how do you just get multiplied to -1?
Well, remember multiplication. If I had -1 times A times B times C, I wouldn't take the -1 to everything. I could just say, oh, well, that's -A times B times C. Right? I don't want to take it to everything. The only time I distribute through like that is if there's plus or minuses.
Could you show me what you just did and why you were able to divide it?
Right. So this piece becomes positive and moves to the bottom of the fraction because of its negative exponent.
I would not know that.
The second piece, which the one underlined in purple here, that is the derivative of the inside. That's the chain rule. The outside, so think about this as being u to the -1. If I did the derivative of that, that's -u to the -2. That's the power rule. But because of chain rule, I also have to do the derivative of what was inside. No, you're done. You're done now.
I never said it was about math, I just said it was going to put YouTube video.
Right. This is where chain rule comes in. Let's do another one. Clearly, let's do another one with like this.
You can take negative exponents from the top, move by negative time. That's so stupid. I don't even understand.
That's just algebra.
No, I am.
Let's do 22. Y equals 1 plus, maybe this one will be a little bit easier because it's a little more straightforward trig function here. All right, find dy dx.
Okay, so the first thing we're going to do is we're going to move that whole around, right? The 2.
Man, you have to stop talking like that. All right, so the first thing I'm going to do is power rule because I want to do the whole outside first. Think about this as being y equals u squared, where u is 1 plus cosine 2x.
Wait, could we just get, so whenever we bring that 2 down, do we just get rid of it?
Right. So the derivative here would be 2 times 1 plus cosine 2x. And you're right, that's just one. This is actually a little bit harder. Times, what's the derivative? It's a double chain rule. You're exactly right. This is a double chain rule. Take the derivative of the inside. So this is chain. What is the derivative of 1 plus cosine 2x?
Negative cosine times 2.
Negative sine 2x. And why saw it first? Chain again.
Oh my gosh. Double chain.
A double chain.
I got 2 chains.
Now understand this is all multiply all the way through. I can multiply in any order I want to, yes? 4. That one makes more sense. I think because it's a straightforward, it's one of the basic trigs is why. You could make that -4 in front, make that sign positive if you wanted to, but there's really not much else you could do there. Van, stop. Yes. Yeah.
Okay, now y'all are cool. Please. Brain break.
No.
It's time to talk about it.
All right, so you're on page 165 and you're doing 1 through 24.